is the electric circuit in a clothes dryer contains two heaters X and Y in parallel. The above figure shows the circuit connected to a 230 volt power supply. When both switches are closed, the current in X is 3.5 ampere. And analyze the circuit given above and answer the following questions. Calculate the power developed in heater X. And if the resistance of X is double that of Y, calculate the current in heater Y. So here we can see that the two resistance X and Y are connected in parallel, which in turn is connected to 230 volt power supply. So when switch S1 and S2 are closed, this circuit looks like, if we redraw the circuit, and now it is given that current in X is 3.5 ampere. Now for problem 1, we have to calculate the power developed in heater X. Since X and Y are connected in parallel to 230 volt power supply, the potential difference across both resistances are equal, that is 230 volt. So we can easily calculate power developed in X, as we know equation of power P equals to V into I, that is potential difference into current. So here current in resistance X is given as 3.5 ampere, and we can see that potential difference against resistor X is 230 volt. So power developed in resistor X, Px, equals to 230 into 3.5 watt, 805 watt. Now for the second problem, we have, if the resistance of X is double that of Y, calculate the current in heater Y. The resistance of X is double that of Y. So we can write that if resistance of X is Rx, then Rx equals to 2 into Ry. And we have Rx by Ry, the ratio as 2 by 1. Now since potential difference across two resistance X and Y are same, that is 230 volt. So if current in X and Y is Ix and Iy, then we must have Ix by Iy equals to Ry by Rx. According to Ohm's law, we know I equals to V by R, and when V is constant, we can write I varies as 1 by R. So Ix by Iy equals to Ry by Ix, or Iy equals to Ix into Rx by Ry. And current through resistor X is given as 3.5 ampere, and we have already calculated Rx by Ry as 2 by 1, so we get 7 ampere. So 7 ampere current flows through resistor Y. Here is our second problem. A circuit is given with two resistors R and 2R, which are indicated as X and Y. And the problem says the above figure shows two resistors X and Y connected in series to a battery. The power dissipated for this combination is P1. When these resistors are connected in parallel to the same battery, then the power dissipated is given by P2. Find out the ratio P1 by P2. Let us take the electromotive force of the battery as E, and we can see that two resistors X and Y of values R and 2R respectively are connected in series. So here equivalent resistance will be R equivalent equals to R plus 2R, that is 3R. So current I in this circuit must be E by 3R, and power dissipated for this combination P1 equals to I square into R equivalent. That we get E by 3R whole square into 3R equals to E square by 3R. This is our first equation. Now when these two resistors are connected in parallel, we can redraw the circuit. So here we do not necessarily need to calculate the current I dot in this circuit. Since the resistors are connected in parallel with the battery, so potential difference across each of these resistors must be equal to the EMF of the battery. So we can use the formula for power as P equals to V square by R, and we get power dissipated in this case P2 equals to power dissipated in resistance to R, that is E square by 2R, and power dissipated in resistor R, that is E square by R. So that will be equal to 3 E square by 2R. So we get P1 by P2 E square by 3R into 2R by 3 E square, that is P1 by P2 equal to 2 by 9.